Now, we will discuss the other machines that you use, the machines which are known as coarse cleaning equipment. And here there are three machines which are normally used. They are known as step cleaner, axi flow cleaner or monocylinder cleaner. They all come under the category of coarse cleaning equipment, and they are generally used right after the bail opening devices, either bail opener, bail breaker or automatic bail opening devices, whatever it is. So, these are the machines whose primary job is to clean. So, general design feature is material is processed while it is in free flight, and while it is floating in air, we will be processing the material in that particular state. The striking elements are widely spaced. Here there is no undue compression to the material as it undergoes processing. Okay. And the opening efficiency of these machines are very poor or mild, because their primary job is to clean, and accordingly it has been designed, and therefore, their opening efficiency is not so good, but cleaning efficiency is excellent. The opening cleaning element is housed within a cylindrical low pressure chamber, so that dust cannot escape the chamber, as air pressure is much more outside than inside the machines. And the housing provides safety to the operators. So, therefore, it is housed within a chamber. The tufts thrown by the centrifugal force of the beating elements remain within the chamber. First machine in this category is known as step cleaner. Now, the machine, a cross sectional view is shown here. It consists of a series of drums, like see here 1, 2, 3, 4, 5, 6 drums are there, and with each drum is having 4 rows of striking elements or fingers on the surface, and they are all lined up in an inclined plane. The grid bar covers 25% of individual drum chamber, and these are the grid bars shown here. The baffle plates are there to prevent from creating circular air current by deflecting the air generated by the rotating drums, and the drums are enclosed in a rectangular chamber. This is the typical design, and there is a trough entry and there is a trough exit. The technical data, if we look, inclination angle around 45 to 60 degree. The drum diameter could be 10 inch typical, it can slightly vary from manufacturer to manufacturer. The fingers height is around 4 inch. The grid bar covers 25% already stated. Distance between the drums is around 19 inch or 48 centimeter. Speed is around 500 to 600 rpm, it could be any value in this range. So, speed is not really very high, and the surface speed one can calculate at the tip of the fingers, which could be 800 to 860 meters per minute, and the cleaning efficiency could be 9 to 12% depending upon the type of cotton, the trash particles in it. So, that is what it is, the constructional details. Now, if we look at the working principle of the machine, then the tufts are fed at the bottom of the drum. So, this is the tuft entry points. These drums, the first drum is going to act on the tufts, and what is going to do? it is going to drag the tufts over this grid bars, and when these tufts are moving over the grid bars, lot of trash particle will fall in the trash chamber, and the tufts will move from drum 1 and will go towards drum 2. So, drum 2 is going to now pick up the tufts. So, if we see the action between the fingers of two drums, then what is going to happen is that if there is a tuft as shown here, in the interacting zone, one striking element is moving up, the other striking element as shown here is moving down. That means, if you look at the drum rotation, the rotation of the drum is clockwise, but in the interacting zone, the fingers are moving in the opposite directions to each other. So, though the drum rotates in the same directions, at the interacting point, the striking elements are moving against each other, and if one tuft is held by the striking element in one drum, the striking element of the other drum is going to act on it, and now the tuft is going to be shared into two pieces or maybe multiple pieces. That is what is going to happen here. So, whenever it is going, so all these drums are rotating, and there is a possibility that there is a mild opening action in between by the fingers of this tuft little bit, but not much, and the tufts will be dragged over the grid bars. So, similar kind of action we found in the case of your bell opener also, where the striking element of the spikes of the inclined spike lattice and the spikes of the Wiener roller are interacting on a tuft. Similar kind of action happens here also. The striking fingers of the two drums move in the opposite directions at the interaction point, and the tuft gets teased out. The receiving drum picks up the tuft and passes it over the grid bars under it, and while it is passing over the grid bars, lot of trash particles will fall down. The process continues, and the tufts moves from drum 1 to drum 2, drum 2 to drum 3, drum 4, drum 5 and drum 6. Gradually it is moving up and up. That means, I am forcing the tufts to move against gravity. So, naturally heavier tufts will take more time to move up, lighter tufts will move fast, and therefore, heavier tufts will be treated more in comparison to the lighter ones. The speed being low and the tufts are in free flight, fiber damage is minimum here also. So, we are not gripping the tuft and then beating by any other striking elements. So, therefore, the opening efficiency is relatively much less, but the nature of opening is quite mild and gentle in nature. The arrangement of the drums, if we discuss that, this question may come in our mind, why these drums are inclined at a certain angle. What will happen if we keep it vertical or if we keep it horizontal as shown here? What is the reason of keeping all the drums at an angle? Now, if we horizontally place the drums, it will cause the tuft to pass through the chambers too fast, because then there is no effect of gravity on the tufts. So, the tufts will pass through the chamber very fast, and therefore, they will not receive the treatment that they need. That is what will happen, and it will also increase the space requirement of the machine. If we place all the 6 drums horizontally, I will be needing more space. So, more space is required. At the same time, the cleaning time will be less because the tubs will pass through faster. That is why horizontal arrangement, horizontal configuration is not used. The next one comes the vertical. In the vertical configuration, it will require minimum space. So, space wise it is very attractive, but it will take a lot of time for the tubs to move up because of the gravity. Many of them will fall down and they will be over treated. That possibility will be there if we have all the drums vertically up. So, this problem is there, and tubs will be overworked because they will not be able to move easily upwards. So, they will be repeatedly treated by the striking elements of the drum. So, hence the vertical arrangement also is not preferred, and an angular arrangement is therefore is the optimum that is chosen by the machine manufacturers, and that angle is 45 to 60 degree. Now, we go to the next machine, which is known as AxiFlow or dual roller cleaner. So, different manufacturers give different names. So, these are commercial names which is given to them, but structurally they are similar and their working principle is also similar. The names may be different, it can vary from manufacturer to manufacturer. Okay. Now, this is an AxiFlow or dual roller cleaner. Now, if you look at the general design feature, then the 2 drums are mounted parallel to each other. So, you had in the diagram the 2 drums are there, A and B, and they are parallel with respect to each other. And this entire thing in the lower part of the 2 drums, we have grid bars, and then the entire the drums and the grid bars, everything, they are now put into a box or a chamber. The drum surface is riveted with 6 or 8 rows of striking elements or fingers projecting out perpendicularly. These pikes or fingers, whatever you say, are arranged in a spiral formation on the drum surface. The lower surface of the drum is covered by the series of grid bars as shown here, and there are inlet and outlet to the machine. So, there is an inlet through which the tubs will enter the machine, and there has to be an outlet also always, and there is a place below the grid bars where the trash particles will fall down and settle. The adjustable guide avoid circulation of tubs, and hence we have an adjustable guide. The technical data is given here. Drum diameter is given 40 to 60 centimeter, almost close to half a meter. Length of the strikers is 10 centimeter, rotational speed could be 400 rpm, air velocity at the inlet is 1200 feet per minute, that is 365 meters per minute or around 6.1 meters per second. Surface speed at the striker tip is 760 meters per minute, and production rate is 500 kg per hour, and cleaning efficiency is superior to the state cleaner. It is 15 to 22.5%. The dead airspace below the machine for trash accumulation, that is at the below the machine. The machine is connected to a suction unit, and through the suction we are basically bringing the tubs within the machine and taking it out also. So, the opening principle is buffeting during free flight. So, they are actually floating in air and the striking elements on the rotating drum is acting on them. So, as tufts along with the air enters the chamber, what happens? There is a drop in air pressure within the chamber due to sudden expansion of air volume. Hence, the tufts entering the chamber falls on the drums. If you look at this diagram, there is another view of the same machine, a kind cross sectional view, but cross section from other directions. So, as soon as the air and the tuft enters through this inlet, what happens? There is a sudden expansion. So, the air suddenly expands, the moment it expands, there is a drop in velocity of the air, and the result of that is the tufts will fall down, you will try to fall, most of them will try to fall, and where they are going to fall? They are going to fall on the surface of the drum or the cylinder, where we have spikes and this drum is rotating at a certain speed. So, they have been caught by the drums, and what will happen? There is a buffeting or agitation which will take place. Say the tufts caught by this striking element of the drum or the fingers of the drum will be turned, or the will be made to rotate at a speed of 400 or 500 or 600 rpm, and as a result high centrifugal force will act on the tufts and on the trash particles also. The tufts will be dragged over the grid bars, causing trash particles to be liberated, and also it will cause some trash particles to fall down. So, since they will be thrown by the centrifugal force, so trash particles will be falling down also, and at the same time there will be scraping action as the tufts will be dragged over the grid bars. So, a lot of scraping action will be there, a lot of trash will be liberated, and some of them also will fall down. The airstream being above the drum, as both inlet and outlet from the chamber are located above the center of the drum. So, if you look at this, that the inlet is here, the outlet is here, only very light and smaller tufts may follow a straight path and go from inlet to outlet. It may happen with some tufts, but majority of the tufts which are heavier and larger, they will be falling down on the, because when the tufts are entering the chamber, tufts are of varying size, some of them are small, some of them are little large, some of them are very open, some of them are dense. So, very smaller and opened out tufts may follow a straight path and go to the other end of the machine, whereas heavier ones will be acted by the drum. The rotation of the drum will cause the tufts to follow a spiral path as shown here. It can follow a spiral path, basically means it will spend more time within the chamber, and if it spend more time, there is more opportunity for the trash particles to be ejected. So, hence a spiral path is beneficial from the cleaning point of view. And by the time the tufts will reach the other end, it will move out. So, this is how the machine is working, and because the tufts are acted by the striking elements when they are in free flight, and hence the opening possibility or opening capability of the machine is much less, whereas cleaning action is very high. monocylinder cleaner is basically a similar machine. Instead of 2 drums, we have only one single drum. This also is used. So, sometimes we have a single drum, otherwise from the point of view of basic design and the way the working principle is more or less is exactly same. Design feature is similar to Axiflow cleaner, but having only one single drum, that is the only difference. There is an inlet, there is an outlet, otherwise exactly same. Working principle, the tufts enters the machine at right angle to the beater axis and experience collision with the strikers and immediately get accelerated. So, as soon as they enter, these tufts will be caught by the striking elements of the drum and they will be made to follow a circular path. So, they will be subjected to high centrifugal force, not only tuft as well as the trash particles. So, trash particles will be ejected from the tuft and they will be falling down, whereas the some tufts will also be rubbed against the sharp edges of the grid bars. The tufts will pass over the grid bars and thrown upwards into the hood. The hood has guide plates as shown here. The guide plates are fitted at an angle to the beater axis in the hood. It will compel every tuft to follow or to fly around the beater along a spiral path. So, to make sure that it follows a spiral path, so that it spends more time within the machine, the hood has guide plates and which are arranged in an oblique manner with respect to the axis of the machine, and it will force the tuft to follow a spiral path. Idea is that they should spend more time within the machine. Unless they spend sufficient time, if they quickly pass through, the cleaning opportunity will be lost. So, here no possibility even for the smallest tuft to pass straight from the inlet to the outlet. So, they have to all spend sufficient time and then only they can move. The other machine similar category is also known as UniClean. So, you see it is name wise it is different, but structurally it is more or less similar. The working principle you see it here, that we have only one beater with spikes on their head and the material entry is vertically downwards and exit is also vertically upwards. So, the location of the exit and entry point of the tufts in the machines may also vary from manufacturer to manufacturers. It is a cleaning and dedusting machine for all types of cotton. Impurities are generally treated and effectively removed. Method of operation, the material enters via pipe. The baffle plates guide the tufts in a spiral several times over the beater. So, the baffle plates are there and they are placed at an angle and hence the tufts will be made to follow a spiral path like we have seen earlier. Tufts are in free flight. So, they enter through this and they are acted by the beaters. In the same fashion, the trash particles will fall down and the cleaned up material will be moving out as shown by the exit. The waste is removed periodically via this stripper roller and through the pipe. Maybe this is then a waste exit also is there, and the clean material is drawn off and transported to the next machines. And part of the incoming transport air is drawn off via the perforated plate. Through this plate, part of this air, the air and tuft are coming together here. Part of the air will be removed through this perforated plate and then these tufts are going to be acted by the beaters and they will move out. This is the material exit as shown in the diagram, and this is how the machine is going to work. So, the working principle is exactly same as we have seen for the previous machine. With this, we close the machines which are used in the blow dome. In the blow dome, that is the machines which are used in the very first few machines which are used to clean the tufts. These are that kind of machines. We will discuss about the other machines which are a little bit more aggressive on the tufts in the next lecture. Thank you.